Hey class, Mr. Moynihan here with a video lesson regarding an introduction to the idea of triangle congruence proofs. This is a topic a lot of geometry students typically struggle with, so I figured we'd launch with an example to actually figure out what it's all about and some important things to keep in mind while doing congruence proofs. So let's go ahead and dive in. We've already seen that there are 4 criteria used to prove whether or not two triangles are congruent. Those 4 criteria are side, 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 angle, side, angle, angle, side, and angle, side, angle. So until now, all we've done is basically recognize if we have one of those criteria present. We haven't really done anything in the process of figuring out what to do with that observation. So far, it's just been, are they congruent? The question now is, how do we actually prove whether or not things are? And there's a couple things to keep in mind before we go into it. One of them we saw from the computer lab lesson, which is called the reflexive property. If you've forgotten, reflexive property is sort of the mathematical equivalent of common sense, or duh. Reflexive property is used to say when something is congruent to itself. When something is congruent to itself. When is it used? It's used in proofs, and it's used in proofs when you have a shared side or shared angle. So one thing that we'll see in just a moment is when you do proofs, you basically have to list out your evidence in a sort of orderly, organized manner, and you have to give reasons for your statements to justify why they're actually true. And when something is the same as itself, you can't really say, well, because it is. The reason for that is called the reflexive property. Now, more often than not, we'll be seeing shared sides, but every once in a while, you do see a shared angle as well. The next thing to keep in mind is an acronym. It's called Cpctc. What does it stand for, you wonder? It stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. You can see the acronym here. It's a bit of a mouthful, but what it's saying is actually something very, very simple. It says that if two triangles are congruent, in other words, if I have a shape like this, and we've already established through a proof that these two shapes are congruent, right? So if you have that, then the consequence is parts in matching positions, or corresponding parts, or things that line up properly, will themselves as individual pieces also be congruent. So for example, let's say this was called triangle ABC, and we had already established through a proof that it's congruent to triangle DEF. Well, if these two shapes are congruent, this is saying that the matching parts are also congruent. So for example, even though it's not given per se that EF is congruent to anything, if the overall shapes are congruent, then we know that EF, by consequence, is going to be congruent to its corresponding pieces of BC. So the parts that match up, essentially, individually, the parts of the triangles will be congruent if the overall shapes are. Some important things to keep in mind when doing proofs, because some information will be given, but a lot of it won't be. Important things to keep in mind include vertical angles. We've already established that those are congruent, and those are a useful tool to find some additional angles. What else? You want to make sure you keep an eye out for alternate interior angles. And remember, for them to be congruent, the lines must be parallel. Right? So just because two angles are alternate interior doesn't mean they're the same. Only when the lines are parallel is that necessarily true. A couple other things to keep in mind are shared sides. We've already seen that as well. And of course, that's an example of the reflexive property. Other things to keep in mind include making sure that given information is marked in the picture. So just because it's given in text doesn't necessarily mean it's going to be visually present. And since most of us can at least get some information from our eyes rather than just reading things, making sure that the picture tells you the full information is also important. And lastly, at least for now, keep an eye out for given definitions. Sometimes you'll be given a certain description of something, and just because you're given that description doesn't necessarily mean you're given the consequences thereof. And we'll see more of that in class a bit later this week. But just keep in mind, when you see the word bisect or midpoint, those might be given to you as part of your initial evidence. You then have to use your own knowledge of those definitions to actually prove what those consequences are of those definitions. So that'll become a bit clearer later on. So let's go ahead and dive in through a particular example here with all this sort of right now in abstraction. How can we actually put it in a more concrete form? Well, let's take a look at this shape right here. We're given this shape, and we're given that angle C is congruent to angle A. And we're also given that segment HA is parallel to segment TC. Now, if you take a look at the picture here, you'll see that none of that information is actually marked. So remember, one of the things to keep in mind in a proof is make sure the given information is actually in the picture. So before we even get into the nuts and bolts of this problem, let's go ahead and make sure that the picture matches the text. So C is congruent to A, so I'm going to go ahead and mark those angles as congruent, because we're given that, so that's not an assumption or anything. We're given those are congruent. We're also given that HA, which is this top segment, is parallel to TC. So I don't know how long they are. They might be the same length, they might not be. But what we're given is that they are parallel to each other. So those little arrows indicate that. So now that our given information is actually visually present, and that's good. So our goal, you'll notice, our proof, is to show that CH is congruent to AT. In other words, this segment is the same length as that segment. Now you might think, well, we've been talking about triangles, and nowhere in this problem does it say anything about triangles. So before we actually get into the proof, let's go ahead and stop for a moment and make a plan. So what is our overall goal? Our goal is to show that CH is the same as AT. Well, how do we do that? Before we get to there, our sort of secondary or first goal to eventually accomplish this, the first thing we need to do is to prove two triangles congruent. Because if we can establish that two entire shapes are the same, we can then use this idea of Cpctc, that if the shapes are the same, then so are their parts. We can use that idea to actually prove what we want to prove, CH and AT. So if you take a look, there are two triangles in this picture. It looks as though this triangle here is probably going to be congruent to this triangle here. So our goal initially is to prove that those two triangles are the same. Well, to do that, you need to use one of these criteria, right? So if you take a look, we're given an angle and a parallel line, but that's not really anything, in terms of sides or angles per se, in terms of the length. And that's it. Well, you might notice we have a shared side here, so that's probably going to be useful. So keep that in mind. So how do we prove two triangles are congruent? We're going to use the shared side. That's going to allow us to make a statement. And secondly, one of the other things to keep in mind is alternate interior angles. Well, if we have parallel lines, we've already established that alternate interior angles are congruent. So we're also going to use that fact. So use alternate interior angles. Now if you take a look, we have, we're given one pair of angles, right? So let me go ahead and mark that as a piece of given information, and I'll just label it here as an angle, right? And we're planning on using a shared side. So this shared side here is probably going to show up in some form as a side. And we're going to use alternate interior angles most likely because of these parallel lines. So we have two pairs of angles, the given and the one we're going to establish, and the pair of shared sides. So we're probably going to be using either one of these two. So at this point, it looks as though this problem is either going to be ASA or AAS. Most likely. This is just a plan, right? The second part of our plan is once we've established that these two triangles are congruent as a whole, we're then going to use Cpctc, which again is a fancy way of saying if the shapes are the same as a whole, then so are their individual pieces, right? So use Cpctc once the shapes are congruent to establish this final fact. So, it's a lot of planning. Let's go ahead and see if we can put our plan into action. You always start a proof, always with the given information. So we're given that angle C is congruent to angle A, and we're also given that HA is parallel to TC. And why is that true? Because it's literally given to us. Statement number 2. What else can we say? Well, we've already sort of hinted at the fact that this shared line is probably going to show up in both parts of our triangle, right? It's one part of this triangle, and it's also the same part of that triangle over there. So we can say that HT is congruent to TH. And the reason for that is, again, you might think, well, duh, of course HT is the same as itself, but the mathematical equivalent of duh, so to speak, is the reflexive property. So now we have our pair of sides that is the same as itself. So I'm going to go ahead and mark that. I'll mark it in red just to show that it wasn't given. Although it didn't quite stick to that color coding, but you get the idea. Well, we've got to be careful about our alternate interior angles here. So if we take away some of the unnecessary markings for the moment, we're looking for a pair of angles that are created by these parallel lines. So you have this top line here, which is HA. You have this bottom line here, which is CT. And you have this transversal HT. Well, hopefully you see that we have a couple of alternate interior angles, but the only ones that we know for sure are going to be this one, which sort of matches right there, and this one here, which sort of matches right there. Remember, we do not know that these are parallel, right? They could be, but we don't know that yet. All we know is the top and the bottom are. So if these are parallel, then our alternate interior angles are right here. So what that means is this angle is going to be congruent to this angle. So let's be careful about how we name them, because order does matter. The name of this top angle could be AHT. AHT, that's this angle right here. That's going to be congruent to, well, A to H to T is the same as C to T to H. C, T, H. Why are those angles the same? Not because they're given to us, not because they're congruent. That's just a circular argument. They're the same because they are alternate interior angles. So now we have a pair of angles given, another pair of angles that we've just established by alternate interior, and a pair of sides that are the same as themselves. So if you notice, we have enough information to use one of our criteria. And if you look carefully, we have an example of angle, angle, side. Why? Because the side is not contained within the two, or not between the two angles. So now we can state definitively that by angle, angle, side congruence, the entire shape, CTH, the entire shape as a whole, is identical to or congruent to CTH is the same as AHT. Oops, AHT. The entire shapes are the same, right? So the shapes are the same because of AAS. That's still not our goal yet. Our goal is to say the parts of the shapes are the same. Well, if you look carefully, C and H represent the exact same spots in the name as A and T. And if the shapes are the same, which we've just established, then it only follows that their individual corresponding pieces are the same. So if the shapes are the same, see step 4, then it only follows that CH is congruent to AT. Why? Because corresponding parts, matching pieces, of congruent triangles, step 4, those congruent triangles themselves are congruent. And if you notice, that was our goal. We started with a given. We used a logical deduction argument to establish why these pieces are identical. Alrighty, I'll see you in class.